Today we will learn Knoevenagel reaction. Knoevenagel reaction, it is a reaction of aldehydes and ketones with active methylene containing compounds like diethyl malonate or malonic acid in presence of base to give alpha beta unsaturated compounds. Now we see the example as acetaldehyde is created with a malonic ester, that is a diethyl malonate. Active methylene compounds are those compounds that methylene group is attached to strong electron withdrawing group. It is IUPAC name ethanol diethyl malonate is created in presence of base like ammonia or pyridine, any amines organic bases, to give rise to initially alpha beta unsaturated compound here, that is COOAT. Further, on hydrolysis and on heating, it undergoes decarboxylation, and finally here we will get the product as alpha beta unsaturated acid, COOH. This is function group acid, this is alpha carbon and this is a beta carbon, hence it is an alpha beta unsaturated acid. Commonly it is an crotonic acid, common name crotonic acid. IUPAC name, select the longest chain from the principal functional group here, functional group 1, 2, 3, 4. Double bond is present in between second and third carbon. It is an butanoic acid. IUPAC name. Now see here, this is a simple reaction. If you take aldehydes or ketones, comparatively the ketones, the aldehydes are more reactive. As we know that the nucleophilic addition reactions, the aldehydes are more reactive. And here the diethyl malonate, this active methylene compound, that is CH2, is more reactive since it is attached to 2 electron withdrawing group, that is COAT ester. Now these two ester group increases the acidity of that active methylene compound, that is CH2. Hence, in presence of simple base, it will be undergoes the condensation reaction. Now, secondarily, either there is a possibility of self condensation of acetaldehyde like aldol condensation. As we know that in aldol condensation, two molecules of aldehydes which containing the alpha hydrogen, here the acetaldehyde is containing the alpha hydrogen, it may be undergoes the condensation reaction to give the aldol in presence of base, but here it does not undergo aldol condensation. The reason is that compared to the acetaldehyde, this active methylene compound, that is diethyl malonate, is more reactive. Due to high reactivity of this active methylene compound, it will be immediately attack on the aldehydic carbon. Okay, that's why this aldehyde doesn't undergo the self condensation reaction due to higher reactivity of this one. Okay, that's why initially it will be attacked and it undergoes a dehydration, that is one of the oxygen here, and these two hydrogen undergoes the dehydration, that is loss of water molecule. We get here alpha beta unsaturated compound here, unsaturated compound, and two ester group on hydrolysis it gives rise to 2COH dicarboxylic acid, but on heating it undergoes a decarboxylation, that is loss of one of the CO2 to gives alpha beta unsaturated acid. Here in this way we can take any example, you can take here any aldehyde and here any active methylene compounds. Now active methylene compounds, which compounds are active methylene? I will see here. CH2 is attached to 2 electron withdrawing group. Here these two are the electron withdrawing groups. Electron withdrawing group. Which groups are electron withdrawing group? In electron withdrawing group, you can take NO2 group, CN group, COH group. Okay, then there is COOET ester. All these are the electron withdrawing group. If you take instead of that this ester, you can take any electron withdrawing group, then we will get this unsaturated compound. Okay, this is the reaction. In general, okay. Now, if you replace this one with suppose NO2 and NO2, we will get here NO2. Okay, simply here NO2 and NO2. Okay, alpha beta unsaturated. This is the general reaction. Okay, particularly if you take the ester and hydrolysis and decarbonylation, you will get the alpha beta unsaturated acid. In this way, this is an Knoevenagel reaction. Now, we will see the mechanism of this reaction. In mechanism part is very important for the organic reaction. On the basis of mechanism, we will understand how a reaction is possible. In first step, the active methylene compound is treated with a base. That is, if you take here pyridine, the structure of pyridine is this one, which has a lone pair of electron. Now, when it is treated with active methylene compound, that is a CH2, COOET, diethyl malonate. ET means ethyl group, C2H5. That is ET is nothing but C2H5, ethyl, short form ET. For methyl ME, like that. Now, here these are the two active hydrogen compounds, active hydrogens. Now, what happens here? The lone pair of pyridine that will attack on the, it means it protonate. Lone pair will take the proton, and whatever the electrons between the carbon and hydrogen will be shipped on the carbon. Okay, then we will get here CH, one of the loss of hydrogen takes place here, COOET, ethyl, COOET. Okay, this carbon will create negative charge, carry negative charge, since it will obstruct the electron. Okay, it is strongly acidic. Once it generates the negative charge, that is the carbanion, now in second step it acts as a nucleophile. In second step, what happens? We having the aldehyde molecule CH3, CH double bond O. You can write the aldehyde plus here CH negative COOET, COOET. Now it will be attacked. This negative charge will be attacked on the carbon, which is electrophilic. As this pi electron will be shifted towards the oxygen, it becomes O minus. Then we will get here CH3, CH. Here this is O minus, and this is the CH, COOET, COOET. In third step, we have to protonate the negative charge. Okay, whatever the negative charge generated, that is ion, oxide ion, CH, this is the O minus, and this is CH, COOET, COOET. Now it undergoes protonation, that is H plus ion. This negative takes the proton and it is converted into CH3, CH. This is an OH, CH, COOET, COOET. In further step, it undergoes the dehydration. Dehydration takes place. CH3, CH, OH, Now this carbon having one of the hydrogen, I will write here COOET, COOET. Now it undergoes dehydration, that is loss of this water molecule H2O. Then what happens? Here this OH will be abstract the electron and this H will use the electron to form here double bond. Loss of water molecule, you will get the alpha beta unsaturated acid. Here alpha beta unsaturated compound CH double bond C, COOET, and here also COOET. It is the basic mechanism formation of the carbon-carbon double bond, that is unsaturation. This is the general pathway for all the alpha beta, that is simply unsaturated compounds. Now in this case we can hydrolyze that ester. If you hydrolyze that ester, it forms the dicarboxylic acid. Et will be converted into H, that is COH. And on further heating, that one of the CO2 will be undergoes, that is decarboxylation, loss of CO2, and here formation of further alpha beta unsaturated compound. In this way, this is the mechanism for Knoevenagel condensation reaction. Okay, this topic.